Hello, Mr. Adam. My name is Manuel Labib, and with my colleagues, Muhammad Adika Zainat and Salsa Bila Shafa, we're here for the high performance polymer fluorocarbon, and it undergoes this presentation. And this is our table of contents. This is the fluorocarbon high performance polymers, which the chemical compounds which contain fluorine and carbon are often referred as fluorinated elastomer, which these fluorocarbons specialize for exceptional chemical and thermal resistance that persuading the low permeability to gases, stability under extreme conditions, resistance to various aggressive chemicals. The key application in industries, which first the history development of fluorocarbon polymers development made debut on the discovery of PTFE by DuPont in 1938. Over decades, advancements in fluorination chemistry led to the creation of elastomer in 1957 by Fitton, which combined flexibility and indispensable in industries requiring materials that can endure extreme conditions. This application in industries, which these first is the electronics manufacturing application, where it used fluorocarbon gases for insulation cables and wires operating in high temperature or corrosive environment. The industrial application, which the fluorocarbon resin coatings used because of their durability and performance. And last one is the chemical processing, which seals and linings for pumps, valves, and storage tanks, handling corrosive chemicals. For the material properties, we have the physical properties, mechanical properties, chemical properties, and unique characteristics. The physical properties, the thermal stability, the fluorocarbon polymers can withstand temperatures ranging from the minus 20 degrees Celsius to 250 degrees Celsius, with some special grades tolerating even higher temperatures. The low permeability, it is the exceptional resistance to gas permeation, making them ideal for sealing and insulation application. And the aging resistance with outstanding resistance to weathering, ozone, and UV radiation, ensuring longevity in outdoor application. The chemical properties, chemical resistance, which superior resistance to a wide range of materials, including hydrocarbon, acid, alkalis, fuels, and solvents. This make them ideal for use in aggressive chemical environments. And the hydrocarbon compatibility, it also perform in contact with oil, gases, and fuels without significant degradation. The mechanical properties, which the elasticity and tensile strength, it maintains flexibility and strength across a wide temperature range, though less elastic than natural or silicone rubber. It is compression set resistance with excellent ability to maintain shape and sealing ability under long-term compression and heat exposure. And the unique characteristic, it is flame retardancy and low smoke emission, non-stick and self-lubricating surface, reducing friction in dynamic application, biocompatibility in specific grades, enabling use in medical and food. The selection criteria, key factors influencing selection is the application environment. It is chosen for application requiring extreme chemical and thermal resistance. The longevity requirements, it is ideal environments demanding minimal material degradation over time. It is cost versus performance, which the fluorocarbon polymers are more expensive than many other elastomers. but their long-term performance often justifies the investment in critical application. In its comparison with alternative materials, such as natural rubber, which the superior flexibility and cost effectiveness for general application, but lacks the chemical and thermal resistance of fluorocarbon. The silicon rubber, it is excellent thermal stability and flexibility, but inferior to fluorocarbon in chemical resistance and tensile strength. And the neutral rubber, good oil and fuel resistance at lower cost, but limited thermal stability compared to fluorocarbon. And the other fluoropolymer, like the PTFE, offers better chemical resistance. It lacks the elasticity and sealing capabilities of fluorocarbon rubbers. The vulcanization in general use the elastomer and the unvulcanized rubber molecules, which consisting the sulfur that makes the cross-linking and the it makes the vulcanized networks. The first one is material preparation. It fills with compounding and pre-forming. The compounding, the raw fluorocarbon polymer is mixed with curing agent. In this fluorocarbon phase is the bisphenol or peroxide, and I can explain it later. And others is accelerators, fillers, and other additives. The mixing is done with manner using equipment like internal mixers or two roll mills to achieve the homogeneous compound. And the pre-forming, the compounded metal is shaped into the mold design. The mold preparation to its cleaning and application of mold release agent to prevent its sticking and ensure easy part removal. The third one is it goes to the loading the mold and continuing with carefully applying heat and pressure to justify the temperatures between the 160 degrees Celsius to 200 degrees Celsius, depending to the fluorocarbon formulation. To its pressure, typically high pressure from 2 until 6 megapascal is applied to compress the material and fill the mold completely, which can be ensuring the proper shape and surface finish. The cross-linking reaction, when the heat activates the curing agents, triggering chemical cross-linking between polymer chain. The cross-linking process forms a stable three-dimensional network enhancing the material's thermal, chemical, and mechanical properties. The curing time varies based on the material, thickness, and design, usually lasting from 10 until 30 minutes. And goes straight to the cooling and demolding. The demolding is the part is carefully removed from the mold to prevent damage to its surface or structure. The post-curing is the optional phase that the parts undergo additional heat treatment at a controlled temperature to further enhance their chemical and thermal stability. And throughout the inspection and finishing, and the last one is quality testing. The curing techniques is the first one is the bisphenol curing. It is the most common techniques for the fluorocarbon on the fluorocarbon polymers because it provides an excellent balance of chemical resistance, thermal stability, and mechanical properties, which these properties is high chemical resistance, especially to hydrocarbon and acids, superior thermal aging resistance, minimal compression set, making it ideal for sealing application, which the application is automotive seals, O-rings, and gasket, and the aerospace component exposed to fuels and oils. The second one is peroxide curing. The peroxide curing currently is employed for specialized application, and in this term, it used for the fluorocarbon, where enhanced thermal stability, mechanical strength, and chemical resistance are required. And it has the properties which the superior mechanical properties compared to the bisphenol curing. It has chemical resistance to strong bases and amines, which can degrade bisphenol cured materials. The applications of the peroxide curing is oil and gas seals, chemical processing equipment, high performance gasket and linings.
For the next is the application and processing technique. And for the application, we choose the gasket, fishing line, and tubes for the fluorocarbon.
In this video tour, we will see various gasket manufacturing processes inside a factory. The process starts with mixing the raw materials in rollers. Then, the rubber is added and removed from the roller continuously. After that, the rubber is made more elastic for the prepared sheet is cut into the... Next, we'll see the silicon gasket making process. Pressed and then shaped. Are heated. Lastly, extra silicon is removed from the...
For the gasket and seal, the manufacturing process, there are three steps, which is the mixing, shaping, and trimming. For the mixing, for rubber gasket, raw material are mixed with the additive to enhance the properties like elasticity and durability. And for the shaping, we use the machine to stem out shapes from the material, and for complex shapes, melted material is injected into molds. And for the trimming, after cutting or molding process, we excess the material is trimmed away. And the gaskets are inspected by for quality. Any defects are addressed before packaging. These are for the specific equipment. There are cutting machines, molding equipment, testing equipment. For the standards, we use the ISO 9001, and for the testing, compression testing, leak testing, and for failure and troubleshooting, the material degradation, the exposure to harsh chemical or extreme temperature can lead to material breakdown. And for the poor installation, incorrect installation can lead to misalignment or improper compression, causing leak. And for the prevention, we compact the with chemical, and we choose a gasket materials that are compatible with the chemical present in the application environment. And for the resistance, temperature resistance, we operate for materials with high temperature resistance to prevent degradation due to extreme temperature. fishing line.
Early fishing lines were made of vines and braided horsehair. But today, fishermen rely on braided. Doesn't mean it's not strong. A single tight cord. An employee starts by threading fibers through needles. She pulls the needles through spring-loaded devices. The devices keep the fibers at an even tension as they unwind onto small bobbins. These bobbins are designed to fit in the braiding machines. The machines are called maypole braiders because the spools spin like dancers around a maypole. As they spin, they weave the strands into a tight braid. There are 4,500 braiding machines in operation at this factory. And adds yellow dye to it, resistant. A gauge measures the line's breaking point. The line to retail-sized spools. It takes about 17 days to braid, color, and process a single.
And for the next manufacturing is fishing line. First one is braiding. The braiding fishing line is made from multiple strands of microfibers, often made from polyethylene or synthetic material. But in here we use the fluorocarbon. And then dyeing. For the dyeing fishing line is a process used by anglers to restore or change the color of their fishing line, particularly braided lines that may fade over time due to sun exposure and wear. And next is for resin. The manufacturing of fishing line involves the use of various synthetic resins, which is a crucial role in determining the line's properties such as strength, flexibility, and abrasion resistance. And for the fishing line, the equipment is extruder, braider machine, and dyeing machine. For the standards, we use the ISO 12875 for the traceability, and for the ISO 12878 is for the environmental monitoring. And testing, we use tensile strength and abrasion resistance. And for the troubleshooting and failure, first one is poor curing. The underheating or overheating during the curing process can prevent the resin from setting properly, resulting in weak or brittle fishing lines. And next is pure extrusion. Inconsistent feed rates into the extruder can cause uneven fishing lines with varying thickness or weak areas. For the prevention, we ensure the proper curing or of fishing lines. It's crucial to monitor oven temperature using calibrate thermocouples to ensure consistent heat through the entire process. And for the pure extrusion, we must make a high quality fishing line. It's important to calibrate the extruder's equipment regularly.
Throughout the ages, artificial light has let people extend the convenience of daylight long after the sun goes down. Fluorescent tubes are more energy efficient than light bulbs. That's probably why they've become a fixture, so to speak, in stores, factories, and offices. 20 years later, Thomas Edison invented his... Did you know that mercury allows us to see in the dark? The production of
for the manufacturing process of tubes, we polymerization, extrusion, and cutting. For the polymerization, The raw material undergo a chemical process called polymerization to form long chain polymer. And for the extrusion, the polymer is melted and forced through the output to create a continuous tube shapes. And as the tube exits the mold, it is cold to harden the material. And for the cutting, the tubes are cut to the desired length, and any excess material is trimmed away, and the surface may be treated to improve addition or appearance. And for the equipment, we use uh, extruder, molding equipment, and testing equipment. For the standard, we use the ISO 1629 and STM the 1418. For the testing, we use mechanical testing and chemical resistance testing. And for the troubleshooting and failure, the material degradation and poor installation. And for prevention, uh, we ensure the correct installation practice are followed, including proper alignment and torque settings during assembly. For the and then regular maintenance and inspection. Conduct routine inspection of installed tubes to identify sign of wear or damage early on.
Moving on to the environmental impact. For the gasket and seal, the first one are greenhouse gas emission. It has high energy and resource demand during production, increased carbon footprint. The second one is environmental risk, disposal challenges due to the material's durability and resistant to degradation, leading to long-term waste issues. And the last one is waste management, limited recycling option, innovation, and reclaiming used seals and gasket is required. The second one is fishing line. The impact of the first one are greenhouse gas emission. The manufacturing of fluorocarbon fishing lines produce emission contributing to climate change, and the environmental risk is lost or discarded fishing line persists in the environment, harming marine ecosystem due to their non-biodegradability. And the waste management is difficult to recycle, often ends up as marine debris. For the tubes, the impact is also a greenhouse gas emission, which production processes emit greenhouse gases impacting climate health. For the environmental risk, tubes that leak or degrade improperly can release harmful chemical into the environment. And waste management, the recycling and repurposing of used tubes are challenging due to their chemical composition and stability. The strategies to minimize environmental footprint. The first one are improving energy efficiency in manufacturing process, reduce overall emission associated with energy consumption. The second one are implementing comprehensive life cycle assessment, helps identify critical stages where emission can be reduced or mitigated effectively. Moving on to the sustainability initiative. The first one are a use bio-based alternative. The researcher is ongoing into bio-based materials that could replace traditional fluorocarbons without compromising performance. The second one are the industry trend. So increase prioritizing sustainability with companies reducing carbon footprint using greener alternative, driven by regulation and consumer demand. And the third one are recycling technologies. Advances in recycling technology are enabling better recovery rates of fluorinated compounds from used product, thereby reducing the need for virgin materials production. The figure above is the example of we collect the fishing line. And next to the future trends and innovation, the first one are advanced production techniques. So the recent innovation in fluorocarbon processing, such as plasma-based and eco-friendly chemical methods, are reducing energy consumption and emission during manufacturing. The second one are smart and functional materials. So development are fluorocarbon materials with self-cleaning, anti-fouling, and anti-corrosion properties for advanced application including marine and medical industries. Third one are expansion in high-tech industries, emerging uses in aerospace, electronics, and healthcare sectors where fluorocarbons are valued for their exceptional chemical resistance and thermal stability. The fourth one are bio-based and sustainable alternative. Researcher is progressing on bio-based fluorocarbon alternative and partially fluorinated compounds, offering similar performance with reduced environmental impact. The last one, an enhanced performance for specific application. So the new formulation provide increased tensile strength for fishing line, improved sealing efficiency for a gasket, and higher flexibility for tubing under extreme condition.
That's all for the conclusion. It is a specialist for chemical and thermal resistance and its application to electrode manufacturing, industrial chemical application. And then there are physical, chemical, mechanical, and the unique characteristic for the key factors influencing selection to its environment application, requirement and cost versus performance. Alternative materials have their own advantage. Next is the manufacturing of fluorocarbon are complex process that requires careful attention to material selection, precise manufacturing technique, and strict adherence to industry standards. To prevent the failures in fluorocarbon tubes, or the manufacturing must implement effective standards, including proper installation technique and quality control measures. Next is fluorocarbon. Materials are essential in industries for their durability and chemical resistance, but pose significant environmental challenges, including high emissions and waste management issues. And then the last one is advancement in recycling bio-based alternative and energy efficient production methods offer a promising solution to reduce their ecological footprints, ensuring sustainable growth and environmental. Okay, that's it. And for the reference, you can see that's all from us. Thank you, Mr. Radha.